Math 1, 8.1. So, use the number line to find the distance between the given points. Notation AB means the distance between points AB. So AE would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. CF would be 1, 2, 3, 4, 5, 6, 7, 8, 9. GB be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. CA 1, 2, 3, 4. BF 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And EG 1, 2, 3, 4. It says, describe a way to find the distance between 2 points on a number line without counting spaces, like we just did. Okay, well, we could take their numbers and subtract them, right? So for AE, A is -4, E is 2. If I go we overcounted, didn't we? These should be each cut in half because they were halves. So 6, 4.5, 7.5, 2, right? 1, 2, 6, and 2. So if we went 2 minus -4, that would be adding, that would end up 6. That's the same thing, right? So we could just take those numbers and add them together, their points, and figure out what they are, doing it that way. Okay? Alright. Now it says find the distance of AB. So 1, 2, 3, 4. BC 1, 2, 3, 4, 5. AC. Now some of you may want to try to count, but we can't do that one. So think about this. This is a right triangle, so if this is 4 and this is 5, couldn't we just go 4 squared plus 5 squared would equal AC squared? So 16 plus 25, which would give us 41, equal AC squared. Take the square root of that, and AC would be square root of 41, about 6.4. So why is it easier to find the distance between point A and B and point B and C than A and C? Because these were on that vertical and horizontal line, so we could count, right? How did we find the distance between point A and C on 10? Well, the Pythagorean Theorem, right? Alright, so it says triangle ABC is a slope triangle for the line segment AB, where BC is the rise and AC is the run. Think back to slope-intercept form. Notice that the length of segment BC has a corresponding length on the y-axis, and the length of AC has a corresponding length on the x-axis. The slope formula is written as y2 minus y1 over x2 minus x1, where m is the slope. So, if we're looking at what it's saying is, to figure out that slope, how far to the right and how far up, okay, the difference between subtracting x2 and x1 gave us the run. For the y2 and the y1, subtracting those gives us the top. Okay, so what does this tell you? That tells you the distance of the rise. This one tells us the distance of the run, or of 2 of the legs of the triangle right here. Okay? So, looking at these, okay, so we wanted, let's see, we found the length of a slanted line segment by drawing, okay, Pythagorean Theorem. This exercise tried to develop a more efficient method of calculating the length of a segment by using the meaning of y2 minus y1 and x2 minus x1 combined with the Pythagorean theorem. Okay, so the idea here is this side would be y2 minus y1. That would give us that length, right? This would be the same with x2 and x1, subtracting those ones. So the idea here is if this is like a and b and c, Pythagorean theorem right here, I kind of want you to see that a is like this. So I could go y2 minus y1 squared and add, and b is like the x's, so x2 minus x1 squared would equal c squared. Then realizing this, we're going to have to take the square root of that whole thing. So in essence, I could go square root of y2 would be 4 minus y1, which is 2, squared plus x2, which was 6, minus y2, which was 2, squared. So that would give me 2 squared plus 4 squared, all under the radical. 4 plus 16, which would be the square root of 20, which if we plug that into our calculator, we'd get about 4.5. It was 4.47, but we'll round up to 4.5. So that distance here was 4.5. Okay? So what this is trying to do here is pull in that idea of the Pythagorean theorem and the distance formula. The distance formula is actually this guy, and it's based off the Pythagorean theorem here. Okay? So if we use this concept, let me write it again. Okay, we can use this when we're given the points instead of the lengths. Okay, so if I use this for 13, and the idea is if I have a calculator that's good enough, I could just type that whole thing in like that and get it to work. So we'd call this y1 or x1 y1, x2 y2. So I'd go 16 minus 1 squared plus 5 minus 2 squared. And those are finding those two lengths, which are like the a and the b, and then you take the square root of it. So we get 15 squared, which is 225, plus 3 squared, which is 9, would give me 234, and it's all under the radical, all of this was. So the square root of 234, and that's my distance, which is about 15.3. Okay, clear that off now. So looking at 14, same idea. Okay, call this y1 and x1, y2 and x2 on that point B. So I'd go the square root of negative 4.5 minus 1.5 squared plus 3.5 minus negative 3 squared. Okay, so 4.5 minus negative 4.5 minus 1.5 would be 6 squared, plus that would be like an addition, so 6.5 squared. So 6 squared is 36. 6.5 squared is 42.25. Add that to 36. We get about 78.25. Take the square root of that. We end up with 8.84. So about 8.8. We'll say 8.84 there. Alright? So 15. We'll do that one the same way we've been doing these ones. So, okay, now it's got P and Q and J and K. So we'd go the square root of y2, call that y2. So K minus Q squared plus j minus b squared. Can we do anything else with that? Nope. So that's where we end up. Alright? Okay, now find the lengths of the segments after you fill things in. Okay, so this has a y value of 6, so everything going horizontally would have 6. Okay, this is an axis, so that would be 0. That would be 0. The y value here would be 0 and 0. The y value down here would be negative 4 and negative 4. And the x values are 10 over here and negative 10 over here. Then HB, so HB would be that distance right there. So this distance we know is 10. And this distance we know is 10. So it would be 20. Now BD would be here. This distance we know is 6 because the y value is 6. This one goes down 4, so 4 and 6 make 10 for the distance. Okay, this one's same idea. These would all be negative 8s. Would be 0, negative 3, 0, negative 3 and 4, 0 and 4, 4 and 0, and 4 here. dB, it's again right there, the x value distance is 8. This one's 4. 8 plus 4 would give me 12. Okay, CF, C down to F, the vertical distance is 4 and 3 because it goes down 3. 4 plus 3 would give me 7. Alright, now it says find the perimeter of each figure below, round answers to the nearest hundredth. So what we need to do is figure out what these lengths are and then add them together. Okay, so 2 ways you can do it. You can find their points and use that distance formula. Oh my goodness, I wrote that totally weird. y2 minus y1 squared plus x2 minus x1 squared. Or we could use the Pythagorean Theorem and make this into a right triangle, the distance of 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. It's the same thing. It's really all what you want to do. So I'll do one each way. So I like the Pythagorean Theorem way better because it seems easier to me. So 4 squared plus 7 squared would give me 16 plus 49, 50, 60, 65 equals, that would be c squared. Take the square root of 65. That's about 8.1. So this side would be 8.1. Which if I look at this, okay, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Same thing, so that's going to be 8.1. Okay, and that's another reason why I like it, because we spot patterns like that. So over 2, down 1, 2, 3, 4, 5, 6. Over 2, up 6. So those two are going to be congruent as well. So I go 2 squared plus 6 squared equals c squared. 4 plus 36. So we get 40 equals c squared. Take the square root. And we get the square root of 40. About 6.3. So that would be 6.3 and 6.3. So add all 4 of those together. And we get 6.3 plus 6.3 plus 8.1 plus 8.1. So our perimeter is 28.8, I think. Let's see. 14 and 14, 28.8. Okay. So that's using the Pythagorean Theorem, which that's my favorite way, making those triangles and then using that to do it. Okay, if we wanted to use the distance formula, we'd find their points. So that point is negative 5, positive 2. That point is positive 2, 6. Then this point is 1, 2, 3, 4, positive 4, negative 2. Okay, so then I do the distance formula 3 times. So square root of a y value 2 minus another y value 6 squared. It doesn't matter which one you call y1 or y2 as long as they match. So notice that I did this y first and this y second. So this x has to be first minus this x has to be second. If not, you'll mess things up. So negative 4 squared plus negative 7 squared, okay, which, notice 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. See, you're coming up with the same numbers, essentially. 16 plus 49 should be, what, 65 again? So square root of 50, 65. About 8.1. Okay, then we do it for our next set. So I go to the square root of 5, or the y value first, 2, minus negative 2, squared plus negative 5, minus 4 squared. So that gives me, that's like plus, so 4 squared plus negative 9 squared. So 16 plus 81, which would be 97. So square root of 97, which would give us about 9.8. So that's 9.8 right there. Okay, then the last one, a y value, 6, minus the other y value, negative 2, squared plus x value, 2, minus x value, 4 squared. So it'd be plus, so 8 squared plus 2 minus 4, negative 2 squared. Negative 2 squared is positive 4. 8 squared is 64. So we get 68. Square root of 68, which is 8.2. And then we add these all up. So 16.3 plus 9, 25.8, be 26.1. Is our perimeter. It's 26.1. Alright, so we've just got these last ones. Now, a circle, hopefully you realize what this radius is, and then realize that you need a formula for that one, right? It won't work to use the Pythagorean theorem here because we're dealing with a circle. So this would be 1, 2, 3, radius of 3. And the perimeter is really the circumference. Okay, so circumference is 2 times pi times the radius. So I go 2 times pi times 3. Pi is generally considered 3.14. Most calculators just do that. So 2 times 6 would equal 12 times pi would equal about 18.85 for our perimeter here. Okay, another triangle here. I would once again make some triangles here because I think that's easier. So that's 4, 3, 1, 2, 3, 4, 5, 2, 1, 2, 2, 3, 4, 5, 6, 7, 8. So I'd have to go 4 squared plus 3 squared would equal c squared. I'd also have to go 2 squared plus 8 squared would equal c squared. And then finally, 2 squared plus 5 squared would equal c squared. To get that side, and this side. So 4 is 16, 3 is 9. So we get 25 equals c squared. Take the square root. We get 5 equals c. So this length is 5. 2 squared is 4. 5 squared is 25. So we get 29 equals c squared. Take the square root of it. Square root of 29 would give us, so 29 square root of that is about 5.4. So we'd have 5.4 here. Okay, then 2 squared is 4, 8 squared is 64, so we'd have 68. Take the square root of 68, get about 8.2. So then we add them together. 5.4 would be 10.4, 8 would be 18.2, be 18.6 for our perimeter. Okay. Now, if we look at 10, we'll do that one first. We've got a semicircle here, but we need to figure out what our radius is. So we'd go, normally circumference is 2 times pi times r, but if we're cutting it in half, it's really just pi times r. So the radius, we could go from this point to here, 2 and the 3, so 3 squared plus 2 squared would equal c squared, or r squared if we're talking about radius, because that's the length we need for our radius. So 9 plus 4, which would give us 13. Take the square root of 13, and we get about 3.6. So that's 3.6. So pi times 3.6 be about perimeter of 11.33 units. Okay, number 9, we've got some horizontal lines. Those are easy to count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now we could use the Pythagorean Theorem, or let's use the distance formula again. So that would be 2, 2. That would be 6, negative 3. So we'd go square root of 2 minus negative 3 squared plus 2 minus 6 squared. Be plus 5 squared plus negative 4 squared. 25 plus 16 would give us 41. Square root of 41 would equal about 6.4, so 6.4 there. Then this one, our point would be 1, 2, 3, 4, negative 4, 2, and negative 6, negative 3. Okay, so we'd go square root of 2 minus negative 3, the y is first, plus negative 4 minus 6 squared. So that would be plus 5 squared plus negative 10 squared. So 25 plus 100. So be 125. Take the square root of that. We get about 11.2. So for our perimeter, we would go 6 plus 6.4 plus 12 plus 11.2, giving us 35.6. And there we go, guys. So, thing to remember, Pythagorean Theorem. We can use that in other instances. And if you really wanted to think about it on a coordinate plane, okay, this is like x2, y2. This is like this point. This is like C, A, and B. This is like x1, y1, that point, second point. And if we realize that A is the same as x2 minus x1, or B, it really doesn't matter, switch in the order, we'll call that B and that A. And then this distance is y2 minus y1. We could substitute y2 minus y1, not y squared, substitute that in for A, plus substitute in for B, x2 minus x1 squared equals c squared. To solve for c, we take the square root, and you get the square root of that whole thing, which is where the distance formula comes from. It comes from that Pythagorean theorem. So, you can either use that by making triangles, or using the points to get the distance formula when you're dealing with that kind of stuff. There you go.